The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
For part B, we want to prove that a sub n is less than 3 for all n, using this exact same formula from the previous problem. Again, to solve this, we're going to need to use mathematical induction. So, we want to prove that a sub n is less than 3 for all n. Remember, for mathematical induction, we need to see base case, we need to assume for a variable, and prove for that variable plus 1. So the base case is of a1. a1 equals 1. That is clearly less than 3, so our base case is done. So now we're going to assume that some a sub k is less than 3. If from this assumption we're able to gather that a sub k plus 1 is also less than 3, then we're done with mathematical induction. So we're going to try to transform this inequality to be a sub k plus 1 is less than 3. So, again, we're going to have to use this formula to try to convert this to an a sub k plus 1. So to convert a sub k to a sub k plus 1, we need to get one side of the equation to look like this. So the first thing we need to do is reciprocate. If a sub k is less than 3, then that shows you that 1 over a sub k is greater than 1/3. So remember, when you reciprocate each side of an inequality, assuming both numbers were positive, which we are going to do here, that flips the inequality sign. Okay, so that looks like this part. Now it needs to be negative. In making both sides negative, we have to flip the inequality again. So now we get negative 1 over a sub k is less than negative 1/3. And finally, we can add 3 to both sides. So 3 minus 1 over a sub k is less than 3 minus 1/3. 3 minus 1 over a sub k is a sub k plus 1. And we get a sub k plus 1 is less than 3 minus 1/3. So here's the problem with what came up here, is that if you notice, this looks pretty similar to our function here, and this is showing you that a sub n would have been 3 in this case. We assumed, though, that it had to be less than 3, and therefore this could not happen, and this inequality then is just vacuously true. Like, we couldn't have had this over here in the first place. So clearly, if a sub k is less than 3, everything else is going to be less than 3. This is one that your teacher might want you to write out a couple of terms with too, and you can show that pretty simply here. Just plug, you're starting with 1, get the answer, plug that back in, do that a few times, and you'll see that it's an increasing sequence that gets closer and closer to 3. By mathematical induction here, we just showed that it's always going to be less than 3 for all n. For part B, we also want to show that a sub n is less than 3 for all n, and to prove this, we're going to be using mathematical induction again. So remember, for mathematical induction, we first need to show that it's true for the base case. Well, our base case is a sub 1 equals 1. That's clearly less than 3, so our base case is done. So now, as long as our base case is less than 3, we need to show that if for any arbitrary k, it's less than 3. If that implies that the next term, k plus 1, a sub k plus 1, is also less than 3, then we know it's less than 3 forever. So what we're always going to start with is assume, for your inductive step, let's just assume that some a sub k further down the line in this sequence is less than 3. If out of this we can show that a sub k plus 1 is also less than 3, then our deal is done. We're proved. So, similar to the previous problem, what we're going to do is, in order to convert this a sub k into some expression of a sub k plus 1, we're going to need to use this formula, because this will give us the next term. So to start turning this into that formula, first we need to do the reciprocal. Since we're assuming also here that a sub k is positive, which is fine to do here. We already showed that it was an increasing sequence in the previous part, and if it's 1 and it's an if it starts at 1 and it's an increasing sequence, it's going to be positive. So we don't need to worry about what happens when you take the reciprocal. If they're positive numbers and you take the reciprocal, you just flip the inequality sign. Okay, so now we need a negative sign, and if you multiply both sides by a negative, you have to flip the inequality again. So now we have negative 1 over a sub k is less than negative 1 over 3. And to finally get us to a part where we could substitute it, we need to add 3 to both sides. Okay, so 3 minus 1 over a sub k by our recursive formula is a sub k plus 1. And 3 minus 1/3 is 8/3. So if a sub k is less than 3, that means a sub k plus 1 is less than 8/3, which is even lower than 3. So certainly a sub k plus 1, if it's less than 8/3, it's definitely less than 3, since 8/3 is lower than 3 in the first place. So by mathematical induction, we have showed that this sequence, no matter which term you have, it's always going to be less than 3.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.